Hello, discrete math fans. Let's prove now that an integer cannot be both even and odd. We referenced this in the past and said that we would get to proving this. Alright, so we're going to use a method of contradiction. So let's suppose, for the sake of contradiction, that the integer n is both even and odd. Now I'm going to use this phrase here anytime I'm doing a proof by contradiction so as to clue the reader in to the fact that that's my goal, is to try to arrive at a contradiction. Remember, what is your primary goal when working on a math problem? It's not to get the problem right, it's to clearly articulate to the reader what you are doing so that they can understand what's going on. So I write this to cue the reader in. Alright, so we've supposed that n is even and odd at the same time. Now what does it mean for n to be even? It means there exists an integer a such that n is equal to 2 times a. What does it mean for that integer to be odd? It means that there exists an integer b such that n is equal to 2b plus 1. Now, on the face of it, this is not necessarily impossible. Maybe you're just not clever enough in coming up with the right integer. Alright, so we know that m is equal to 2a and m is equal to 2b plus 1, so we can go ahead and set those equal to each other. 2a is equal to 2b plus 1. Alright, so if we do a little algebra, we can see that 2a minus 2b is equal to 1, and then if we divide everything by 2, we'll get a minus b equals to a half. Now, a and b are integers, that means a minus b is an integer. But then that we have an integer that's equal to a half, that is a contradiction. There are no integers that's equal to a half. Therefore, no such integer can exist that is both even and odd. Since we have arrived at a contradiction, that proves then that our original supposition was not correct. Okay, that's all for now.